So in this video, we will be going over the quotient rule, and the formula states when we have a fraction, meaning that we have f over g where f and g are functions, the derivative of f over g is equal to f prime g minus f g prime over g squared. So let's do a quick example to understand this. So let's say we need to derive x squared minus 1 over x 3x plus 5. So now we need to follow the formula. So first of all, we need to this is the numerator is going to be f and the denominator is going to be g. So we can write f is equal to x squared minus 1. F prime is equal to the derivative of f, so it's going to be 2x, and g here is 3x plus 5, and g prime is equal to 3. So now we just need to follow the formula. So it's going to be f prime g. F prime is 2x and g is going to be 3x plus 5 minus, this minus sign is very important because in the product rule it is plus, so in quotient rule it's minus, and f is x squared minus 1 and g prime is 3 over g squared, which is going to be 3x plus 5 squared. Now we just need to simplify this, so I'm going to erase this over here and simplify this. So here we are going to multiply 2x by 3x and then simplify this, so it's going to become 6x squared plus 10x, since it's going to be 2x to multiplied by 5, minus 3x squared, let's use the brackets, minus 3, and this is all going to be over 3x plus 5 squared, and we can simplify this to, it's going to be 6x squared minus 3x squared, so 3x squared plus 10x, it's going to be minus 3, so plus 3 over 3x plus 5 squared, and this is the final answer. So go ahead and try this example. So f is going to be the numerator and g is going to be the denominator as always, and f prime g is going to be, f prime is going to be 9, open brackets, close brackets, and g is going to stay the same. And I wrote the formula on the top right just to remind you guys, and we'll take some time to memorize it. So minus fg prime now, so f is going to stay the same, 9x plus 1, into g prime is 4x, and this is entirely going to be above over g squared, so 2x squared minus 2 squared. Now we can multiply and simplify this, so it's going to be 18x squared minus 18 minus, open brackets, 9 times 4 is 36, x squared plus 4x, yeah, over the same thing, 2x squared minus 2 squared, and now we can minus 18x squared by 36x squared, so that's going to give us minus 18x squared and minus 4x, so because this sign is going to be here and multiplied by 4x, so minus 4x minus 18 all over the same thing here, and that would be the final answer. So let's do some examples for trigonometry now. So here we have f as sine x and g as x squared. So what is the derivative of sine x? It's going to be cosine x. So f prime is going to be cosine x and g is going to stay the same, so x squared minus f is going to stay the same now, sine x, and g prime is 2x all over g squared, so that's going to be x4 actually. And now we can leave the answer as this because we cannot simplify it further, but we could multiply it, so it's going to be x squared cosine x minus 2x sine x all over x to the power of 4, and this is the final answer. Now another question you might be asked is, you need to prove the derivative of tan x is secant squared x. So we know this, as this is a rule, and we need to prove it. So here tan is sine over cosine, and here we can use the quotient rule on this. So f is going to be sine x and g is going to be cosine x, so it's going to be f prime g. So f prime is going to be cosine x, g is going to stay the same, minus f g prime, so f is going to stay the same, g prime is going to be negative sine x, since the derivative of cosine x is negative sine x, and this is entirely going to be over cosine squared x. And now we can simplify this, so it becomes cosine squared x minus, and this is going to be negative sine x squared, so it's going to become plus sine squared x. See, since we multiply sine x by negative sine first, so that's negative sine x squared, and then there's a minus sign over here, so it becomes plus, and this is going to be over cosine x. And this is a basic property that you need to know, that cosine x squared plus cosine x squared is equal to 1, so the numerator here is just 1, so 1 over cosine x squared, and this is secant squared, so we proved it. And as I was saying, the property is sine x squared plus cosine x squared is equal to 1. It's a very basic property, and you can try for any angle of x that you put, you will always get 1, and your calculator needs to be in degrees. So here we successfully proved that the derivative of tan is secant squared x. So in our next question, we need to prove that the derivative of secant x is equal to secant tan x. So this is a rule that we already know, that the derivative of secant is secant tan x, and we need to prove this. So we know that the secant x is 1 over cosine, and we can use the quotient rule on this fraction over here. So f is 1 and g is cosine x. So let's start with the formula then. It's going to be f prime g, so f prime is going to be 0, so the first f prime g is going to be 0 entirely, since anything multiplied by 0 is 0, minus, now it's going to be f g prime, so f is just 1, and g prime is going to be negative sine x over g squared, so g squared is cosine squared x, and we can simplify this now, so this will become sine x over cosine squared x, and this can be written as, since secant is 1 over cosine x multiplied by tan, which is just sine over cosine, So this multiplied gives you sine over cosine squared, and this part over here, so cosine, I mean 1 over cosine is just secant x multiplied by tan, as sine over cosine is tan, and we proved it that the derivative of secant x is secant x tan x. Now, as always, there is always a shortcut method for you guys on the calculator. So if you have a calculator, you need a calculator with the derivative option, and you might notice that you need to input a x value. So you might be thinking, what if I don't have a x value? So I even have a shortcut for that. So let's say we want to solve for this question, secant x, and we have MCQ questions, MCQ options, and this is one of the options. So we can put any value, and for the other thing is you need to convert your calculator to degrees. That's the main important step. It shouldn't be in radians, that will give you a wrong answer. So you can substitute x as anything, so let's say 1, and whatever the value your calculator gives you for secant x, let's say it's 0.1381, and you need to note this value down, and in your final answer you will substitute 1 again, and if you get the same answer, this means that your answer is correct, and this works for any of the other questions that we did in this example. And of course I'll be making a short video because it's more easier to explain it if I'm doing it on the calculator rather than this. So yeah, thanks for watching.